Earth never loses a drop of water. It evaporates, condenses, and falls as rain, the same cycle for billions of years. So if water always comes back, why are entire cities running dry? Only 3% of Earth's water is fresh. The amount you can actually drink? A sliver of that sliver, and we're draining it faster than nature can refill. The problem isn't the cycle, it's what we've done to it. Every science textbook shows the same neat diagram. Water evaporates from oceans and lakes, forms clouds, then falls back to Earth as rain or snow. The cycle spins on, endlessly. It sounds like a guarantee, nature's recycling program that never runs out. But here is the catch. Almost all the water making this trip is completely out of reach. Oceans hold about 97% of all water on Earth, and it is far too salty to drink. That leaves just 3% as fresh water, and even that number is misleading. Zoom in on the so-called fresh water. Nearly 70% is locked away in glaciers and ice caps, frozen, solid, and untouchable. Most of what is left is buried deep underground, trapped in rocks or too salty, polluted, or expensive to pump. The water we can actually use, what fills rivers, lakes, and shallow groundwater, amounts to a tiny fraction of a fraction. Picture a 5-gallon bucket filled with water. If you pluck out a single drop, that is about how much is truly drinkable and accessible for people, farms, and cities. So, while the water cycle keeps spinning, it does not mean a steady supply of clean water for everyone. The cycle moves massive amounts of water, but it does not promise that any of it will land where and when we need it, or in a form we can actually use. That is why the next step is to break down exactly where the world's water really is, and why so little of it ever reaches your tap. There is a hidden trio that controls every drop of water you will ever use: quantity, quality, and distribution. First, the raw numbers. Out of all the water on Earth, almost nothing is actually up for grabs. Even within that tiny sliver of accessible fresh water, most of it is not sitting in your local river or lake. It is scattered unevenly across continents, seasons, and even decades. Some places get deluged, others are left bone dry, but that is only the start. Now, quality. Water can be everywhere, but if it is salty, polluted, or laced with chemicals, it might as well not exist for drinking or farming. Pollution and salinization quietly erase huge chunks of the world's fresh water every year. In some regions, more than 1/3 of groundwater is already too contaminated for safe use. So, even when water is technically present, it often fails the basic test: is it safe? And then comes the biggest wild card: distribution. It is not just about how much water exists, or even how clean it is, but where and when it shows up. Rivers can flood one month and run dry the next. Groundwater can take thousands of years to refill, but a single season of heavy irrigation can drain an aquifer faster than nature can keep up. Here's the shocker: nearly 70% of all freshwater withdrawals go to agriculture. That means the water in your morning coffee or the wheat in your sandwich has already traveled the world as virtual water, hidden in every bite and sip. When crops are exported, so is the water it took to grow them. The global food trade is also a global water trade, quietly shifting precious supplies from one region to another. So, the real story is not just about running out of water, it is about running out of usable water in the right place at the right time and in a form that will not poison us. And with most of it already spoken for, especially by farms, the pressure on that single drop in the bucket is only getting worse. Human hands are draining the world's usable water faster than any natural drought. The Ogallala Aquifer, stretching under 8 states in the United States, once seemed limitless, a hidden ocean feeding 1/5 of American crops. But after decades of relentless pumping, water levels in some parts have dropped more than 150 feet. In Kansas and Texas, the aquifer is shrinking by more than 1 foot every year. At this rate, some counties could run dry within a generation. The story repeats across the globe. In Central Asia, the Aral Sea was once the world's 4th largest lake. Today, more than 90% of its surface is gone. Soviet-era irrigation projects diverted the rivers that fed it. chasing cotton profits but leaving behind a toxic desert. The loss of the Aral Sea did not just erase a fishing industry, it unleashed dust storms laced with pesticides, turning villages into ghost towns. But overuse is not the only problem. Pollution quietly poisons what is left. In the United States, about 35% of groundwater is tainted by farm runoff or leaking septic tanks, making it too risky or expensive to drink. Globally, more than 1/3 of shallow aquifers are already contaminated by fertilizers, heavy metals, or industrial waste. Even when water is technically present, it is often too dirty to use. Governments sometimes make things worse. Subsidies for cheap electricity and water encourage farmers to pump even harder. Draining aquifers faster than rain can refill them. The more we take, the less nature can give back. These are not accidents, they are choices, and the losses add up drop by drop, year after year. From hundreds of miles above Earth, satellites are watching our water vanish. NASA's GRACE mission, led by hydrologists like Jay Famiglietti, tracks the planet's shifting water weight. Its maps reveal bright red scars, zones where groundwater is disappearing year after year. Central California's Central Valley is one of the starkest. Here, the land itself is sinking. In some towns, the ground has dropped more than 8 meters since the 1920s, as aquifers below are sucked dry. Farmers who once drilled just a few meters for water now chase it hundreds of meters down, only to find wells turning brackish or running dry altogether. It is not just rural fields at risk. In 2018, Cape Town came within weeks of shutting off municipal taps for 4 million people. The city's reservoirs plunged to just 13% of capacity. Residents lined up for hours, rationed to 50 liters a day, barely enough for a shower and a cup of tea. The phrase "day zero" became a household term, a countdown to the moment a modern city would run out of water. Meanwhile, along coastlines from Bangladesh to Florida, another threat creeps inland. As fresh water is pumped out, salt water pushes in. In South Florida, the salty front has advanced 2 kilometers per decade, contaminating wells that once supplied entire neighborhoods. In Bangladesh, rice farmers watch their paddies wither as brackish water poisons the soil. These are not distant warnings, they are happening now, and satellites are recording the losses in real time. The most unsettling truth, some of the water being lost today took centuries, even millennia, to accumulate underground. Once it is gone, it won't return in any human lifetime. The illusion of endless water is shattered by hard data and by the lived experience of people on the front lines. If you could gather every drop of water on Earth into a single ball, it would only stretch about 860 miles across, smaller than the distance from Salt Lake City to Topeka. Out of that massive sphere, 97% is salt water, totally undrinkable. Just 3% is fresh, but blink and you'll miss it. Nearly 70% of that fresh water is locked in glaciers and ice caps, frozen out of reach. Now for the jaw dropper. If you poured all the world's usable fresh water into a 5-gallon bucket, the share humans can actually drink and use would be a single drop. 5 countries control more than 1/3 of the planet's renewable fresh water: Brazil, Russia, Canada, the United States, and China. Every year, melting glaciers dump enough water to fill Lake Superior twice, but most of it evaporates or rushes away before anyone can use it. Producing 1 hamburger uses more water than an Olympic-sized swimming pool. And here is the wildest twist. Even regions drenched in rain can still run dry, because rainfall does not always fall where or when people need it. So what happens now? The world faces a crossroads. Some cities are racing to capture every drop, injecting stormwater back underground through managed aquifer recharge. But geology sets hard limits. Not every region has the right soils or rock layers for this to work. Others are turning to wastewater recycling, treating used water so thoroughly it can safely flow from tap to tap, shrinking demand for new supplies. Desalination plants are popping up along coastlines, pulling fresh water from the sea at a steep energy cost and with brine left behind. Each path has trade-offs, and none is a silver bullet. The question hanging over us, which route will we take, and will it be enough to keep that single drop in the bucket from vanishing for good? Here's the catch. Nature's recycling isn't instant or fair. Right now, 1 in 4 people face water stress, not because water vanished, but because we are burning through the accessible supply faster than Earth can restore it. The real crisis is not about rain, it is about what is left to drink. Stay curious.